Hey, hello everyone. Up to the last video, we have learned many things. We have done all the questions up to exercise number 2.2 and we have learned some objects there too. But what we are going to do today is that, as you know that we are studying about chapter number 2, fractions and decimals, and we are going to learn about the multiplication of fractions. Multiplication of fractions. Multiplication of fractions. Actually, multiplication of fractions is very easy. It's like a normal multiplication, no rocket science is that. It's very easy, but for if you want to understand it completely, you just want to watch my video to the end. Don't skip the video, don't miss any part, and watch it with a little bit of more concentration. So, for example, if I'm saying I have a fraction that is a by b, we all know that in this a will be called as the numerator and this b will be called as the denominator, right? This a will be called as the numerator and b will be called as the denominator, and I have one more fraction like I'm saying a by b multiplied by c by d. So a and c are the numerators, b and d are the denominators of both different fractions, fraction number 1 and fraction number 2. So if we want to find out the product or if we want to multiply these two fractions, the basic rule says that product of numerators, product of numerators divided by product of denominators, product of denominators. What do you mean by that? Means if we want to find out the product of a by b into c by d, we will do a into c divided by b into d. That is our journal rule. That is actually our journal rule. First we will learn the basic rules how to do it. Then I will try to make you it more easier by teaching you one trick. Okay, so now let us take some examples here. That is question number 1 or example number 1. Multiply a part 4 by 5 into 3 by 2. Multiply 4 by 5 into 3 by 2. As per the general rule, we have to find out the product of numerators. Product of numerators means 4 and 3. So 4 into 3 divided by product of denominators 5 into 2. That will be 4 3s are 12, 5 2s are 5 2s are 10. 4 3s are 12, 4 5 2s are 10. So this is the answer or the product of 4 by 5 and 3 by 2. Let's take one more example here. 9 by 11 into 10 by 11. How we can multiply these products also, or how we can find out the answer of them also. 9 into 10, or we know that the same thing, product of numerators 9 into 10 divided by the product of denominators, that is 11 into 11. 9 into 10 is 90. 11 into 11, the square of 11 is actually 121. So like that we have to do. Let us take few more examples. Let's see what will happen if we are multiplying two improper fractions or if we are multiplying two proper fractions. I hope you remember proper fractions. Proper fractions are actually those fractions in which numerator is lesser than denominator. Proper fractions are those fractions in which numerator is lesser than denominator. Example 3 by 4. numerator is smaller than denominator. 9 by 13, numerator is smaller than denominator, or I can say denominator should be greater than the numerator. 100 by 150, that's also a proper fraction. And what about improper fraction? Improper fraction, yes, as you all know that improper fractions are those fractions in which numerator is greater than denominator. Improper fractions are those fractions in which numerator is greater than the denominator. How we can find out, or what are the examples here? 4 by 2, or instead of that let me write it 4 by 3, 5 by 2, 11 by 7, 100 by 96. These are all like the improper fractions in which numerator is greater than denominator. So let us find out some questions in which if we are multiplying two proper fractions, what will be the answer? If we are multiplying two improper fractions, what will be the answer? Let's take one example A. First of all, I am multiplying two proper fractions. That is 3 by 4 multiplied by 1 by 2. Both are proper fractions, right? And now I want to multiply them. So product of numerators 3 into 1 divided by product of denominators, that is 4 into 2. 3 ones are 3 and 4 twos are 8. Take one more example here. 9 by 11, or instead of that let me take 1 by 4 into 6 by 12, or 6 by 9. Product of numerators 1 into 6, product of denominators 4 into 9, 1 6 are 6, 4 9s are 36. In all these cases, both of the cases, I can see one thing, that when two proper fractions are multiplied together, this is also a proper fraction, this is also a proper fraction. In the second case also, first is a proper, second is also a proper fraction. When both the proper fractions are multiplied together, the result which I am getting is actually smaller than the individual fractions. Means this 3 by 8 is actually smaller than 3 by 4. This 3 by 8 is actually smaller than 1 by 2. If you want, just see one example here, like 3 by 4. Means I am having one circle which is having 4 parts. Out of these 4, 3 are shaded, right? If I am having 1 by 2, that means one circle having two portions, like that. But if I am having 3 by 8, 3 by 8 says that one circle which is having 8 parts, 1 2 3 4 5 6 7 8 parts, and out of these 8 only 3 are shaded, 1 2 3. You can see here which is a bigger fraction. Is this is a bigger, this is a bigger, or this is the bigger? You can say that this 3 by 8 is actually smaller than 1 by 2 and 3 by 4. Here, see the shaded part, how much it is shaded. A great portion is shaded, means 3 portions are shaded. Here half of the portion is shaded, but here only 3 portions out of 8 are shaded. So 3 by 8 is actually smaller than the both of the fractions. So we can say one general rule here, that if two proper fractions are multiplied together, the result which we are getting will actually be smaller than the individual fractions. I hope it is clear for you. Now let's see what will happen if I am multiplying two improper fractions. What will be happen if I am multiplying two improper fractions? Let us see that. Example number A, 4 by 3 into 6 by 5. 4 by 3 into 6 by 5. Product of numerators 4 into 6 divided by 3 into 5 means the product of denominators. 4 6 are 24, 3 5 are 15, right? Let us take one more example. 11 by 9 into 4 by 3. 11 by 9 into 4 by 3, both are improper. 11 fours are 44, or let us write product of numerators into 9 into 3, that is 44 by 9 3s are 27. In this case, when I am multiplying two improper fractions, in this case I am able to see that this result or the resultant is actually greater than the individual fractions. Opposite of proper. In the proper, if you are remembering, the resultant was actually smaller than the individual fractions, but here in the case of improper, the resultant which we are getting is actually bigger than these two individual fractions. 24 by 15 is actually greater than 4 by 3. 24 by 15 is actually greater than 6 by 5. 44 by 27 is actually greater than 11 by 9. 44 by 27 is actually greater than 4 by 3. So individual fractions in the case of improper fraction are smaller than the resultant fraction. I'm repeating my word. In the case of improper, when we are multiplying two improper fractions, the resultant which we are getting will be greater than that the individual fractions. I hope it is clear to you. Now the question arises to everyone, like how to find out which fraction is bigger or which fraction is smaller. How to find out which fraction is bigger or which fraction is smaller. In that case, we have already discussed about this, but just for a quick revision I will tell you. For example, I am giving you two fractions which is greater. 1 by 2 of a part, 1 by 4 or 3 by 4. The question is asking that which is greater, 1/2 of 1 by 4 or 3 by 4. Let us check it. Let me write it. Okay, this is A, so let me write it. This 1 and this is 2. 1 and 2. Let me solve the first part. First part says that 1 by 2 of 1 by 4. This of actually means multiply. So how we will write it? We can write it as 1 by 2 into 1 by 4. Then the product of numerators 1 into 1 divided by product of denominators 2 into 4. That will be equals to 1 by 8. Right? Good. Second case. Let me make it as 3 by 5. Second case. Okay, if I'm making 3 by 4, what will happen? Avoid my confusions. Okay, so 1 by 2 of 3 by 4. Of means multiply 1 by 2 into 3 by 4. That will be equals to 3 on 4 2s are 8. 3 by 8. Now I want to compare which is greater or which is smaller. 1 by 8 is bigger or 3 by 8 is bigger. Let me write here at one corner. 1 by 8 or 3 by 8. In the case when the denominators are same, or I can say that in the case when we have like fractions, it is very easy to compare because the denominators will be same. We just have to look only the numerators. Which numerator is greater here? 3 is greater. So we can say that 3 by 8 is actually greater than 1 by 8. But in the case if the numerators are not same, or the fractions are not same, or the fractions are not like. Do you remember our first videos of the earlier videos of this chapter? In that we have learned how to make these two fractions as a like fraction and how to compare them. First, if you will be able to make them like fractions, then you will be doing like the same. Just look at the numerators. If this numerator is greater, it will be the bigger fraction. So if you want to watch, if you want to know how to compare two unlike fractions, you have to watch the previous videos. So when the question is asking which is greater, you can just do like this, simply multiply and all. So actually this is all much which is given in your textbook, but one thing I want to teach you here now onwards, that is reduction, or the reduction of, or making the fractions into simplest form. That is actually important. Making the fractions into simplest form. Simplest form, or reduction of the fractions. Example, I am saying that multiply 1 by 2 into 6 by 9 or 6 by 7. So according to the conventional method, what I need to do is that 1 into 6, then 2 into 7, then it will become 6 by 14, and then I can reduce it. Then I can reduce it to the simplest form, as you already know that. How I can reduce it to the simplest form? I can reduce it to the simplest form by dividing both the numbers by 2. It will be 6 divided by 2 will be 3, 14 divided by 2 will be 7. This will be the reduced form, or I can call it as the simplest form. But I can do one more thing here that might be easier, like I am checking crossly. I want to check crossly. Means I want to check with the numerator and denominator. Never do the cutting method with denominator or numerator. Always do the cutting method. I used to call this as the cutting method. In my language, I am calling it as. It is not a method or not a particular language given in the textbook. I'm just calling it as my method, as a cutting method. So means might be your teacher is giving this same method as a different method. The name will be given a different. So don't get confused. Whatever the teacher is teaching, that also will be okay. So cutting method. Cutting method means I want to look crossly. Numerator and denominator I want to look. First of all, I'm checking the numerator and denominator of these fractions. Is it possible to reduce them? Means is it possible that they both are coming in the same table? No. But what about 6 and 7? Are they coming in the same table? No. So what I will do is that I will check them crossly. What about 1 and 7? Is it possible for me to reduce it? No, because 1 is already the smallest number. But what about this 2 and 6? Is it possible for me to cut it? Yes. So 1 by 2 into 6 by 7, I am able to see that 2 and 6 are possible to cut. So 2 1s are 2 and 2 3s are 6. Everyone knows how to reduce that. Now what is the remaining portion here? What is baki now? 1 into 3 divided by 1 into 7. So 3 1s are 3 and 7 1s are 7. See, you are getting the same answer in a single step. No need to multiply them first, then reduce them first. I am just dividing them and I am finding out the answer. Check some more examples how to do this by using cutting method, okay? By using the cutting method. Because when you will go in the higher classes, you have to follow this method. That will be much helpful for you. Let us see that 7 into 9 multiplied by 45 by 14. Okay, let's check that. Is it possible for me to reduce these two fractions? This numerator and denominator in the same fraction? No. What about this one? No. But I want to check them crossly. 7 and 14 is possible to reduce. 7 1s are 7, 7 2s are 14. In this case, 9 1s are 9, 9 5s are 45. What is remaining with me? 1 into 5. This 1 into 5 divided by 1 into 2. What is here? 5 by 2. Check, very easy. I'm getting the smallest answer, the simplest answer. Take one more example. 8 by 13 into 26 by 26 by 40. Okay. Is it possible to reduce this? In this case, it is possible for me to reduce now also. In this case, it is possible for me to reduce now because 26 is also coming in the table of 2 and 40 is also coming in the table of 2. I can do this If you want, let us try. If you don't want, just cut them crossly. See, if I'm cutting them crossly, what I'm getting is 8 ones are 8, 8 fives are 40, 13 ones are 13, 32s are 26. What I'm getting is 1 into 2 and 1 into 5, that is 2 by 5. So like that, cutting method is quite easy. Means if we are just focusing on this division little bit, how to cut them, then it's very easy for us to find out the solution in a very quicker way and in a time consumer way also. So I hope you have understood it. If you have liked my videos, if you have loved that the concept little bit, don't forget to like and subscribe my channel. Okay, and share it with your friends too, so that they will also be get benefited. Thank you so much. Try to do this exercise number 2.3. Try to do the exercise number 2.3 after watching these videos. If you're having doubts, just comment in the comment box and share your valuable experiences also in my comment box. Thank you so much. Up to that time, bye bye.